You how to find root of equations using Excel. Here is the outline of our lecture today. First will be the objectives and the learning outcomes, followed by the introduction of the numerical method. Then I will use Excel to solve very important equations in drilling fluids using Excel. After that, I will assign you some home assignments, and finally some remarks. This lecture have only one objective, which is to demonstrate to you how to use Excel to solve practical petroleum engineering problem. The learning outcome of this lecture is, after the lecture, you should be able to use Excel to solve any petroleum engineering related problem by yourself. Now for the introduction, you know that there's many problems in petroleum engineering that require numerical solutions. Because we can't find the solution, the analytical solution. In other words, there's no explicit expression for the solution. Therefore, we have to do it numerically. An example is the jet impact force, and it related to pressure drop to the drill bit and the flow rate. If you are given a jet impact force and you are asked to find what the flow rate to achieve that jet impact force, then you need to solve this equation for Q. Clearly, this equation is nonlinear, so it will be difficult to solve it analytically. The second problems that we often encounter in drilling fluid engineering is the problem that requires you to determine the pressure gradient. To determine the pressure gradient, which is to estimate the frictional pressure loss, you need to find the wound shear rate corresponding to a certain flow velocity. And from the wound shear rate, you'll be able to calculate the wound shear stress and the pressure gradient, given all of the rheological properties of the drilling fluids and the geometry of the pipe. This is for laminar flow of polar fluid flow in drill pipe. And also in production engineering, you might saw this equation before. This equation is the fouling friction factor. If you are given a pressure drop along a pipe, you'll be able to determine the fouling friction factor. And from the flow velocity and other properties like viscosity and density and pi radius, you'll be able to determine the Reynolds number. But you might be asked, what would be the value of relative wound roughness for that case? In this case, this equation will be nonlinear and it's difficult to solve it analytically. All the other cases, when you have to determine the Reynolds number given fouling friction factor and epsilon, then this equation is not linear as well, and you need to use the numerical methods. And today I'm going to use a very simple and straightforward way to solve one of these equations in Excel. Now let's try some example. For example, the pressure gradients can be calculated from this formula, where the The wound shear stress can be obtained from the yield stress, the flow behavior index, and the flow consistency index, as well as the wound shear rate. The wound shear rate is related to the flow velocity from this formula. The question to be asked here is, if I give you all other parameters, I would like to know what would be the pressure gradient when the fluid flow along this 0 pi. Now, to do that, you need to obtain the wound shear rate first by solving this equation. And from the wound shear rate, you obtain the wound shear stress. And from the wound shear stress, you obtain the pressure gradient. This equation is a nonlinear equation and quite challenging to solve for. Therefore, we are going to use Excel to obtain the solution. Let me copy this function into Excel. Then we will try to obtain the solution of this one. Let me put this one as an input here. I will make this one bigger so that you can see it. I put it here, input data. To save the time, I wouldn't put the unit here, but I will put very briefly this one is RP, which is pi radius, equal to 0.0508. This one is tau, and it's equal to 8. This one is K, and it's equal to 0.6. Is that correct? 0.3, 0.3, and N equal to 0.6. That's okay. Now, velocity is 1. Let me give it some name here. For example, this one will be RP, K or tau, U Paulo. This one will be K, U Paulo. This one will be N. And finally, this one is velocity. Now I need to write this formula in this in the space here. I need to write this one here. I need to take this one. I need to write this one here. I put this one right hand side equal to RP underscore P times K U Paulo times N U Paulo, divided by tau plus K underscore U Paulo times gamma, which is this one. Let me put this one as gamma, okay, to the power of N U Paulo. To the power of 3. Let hit enter first for now, and I put this one in gamma here equal to 1, for example. I put it here. Wound shear rate So I already finished this part of the equation. Let me continue with the other part. Times open bracket tau Now we already finished this term. Now next is this one plus. Now we already finished this term. Now the next one is this one. Now we close the brackets, the final one, and hit enter. Hope it works. Yep, it works. Let me check the value for 100. Let's see how much we have. Okay. Now we want the right hand side to be equal to the left hand side. Left hand side is 1. So to do that, we need to do the following. You go into data tab here and you look for what if analysis and you go for go 6. You want to set this value of the cell D3, which is this one, to the value of this one, which is 1, by changing the cell, changing this one, and you hit enter. Say OK. Yep. Then you say OK, then that is the Won shear rate, and it's almost equal to 1. After you obtain the Won shear rate, you should be able to obtain the Won shear stress. Won shear stress. The Won shear stress can be calculated from the yield power law model. Tau plus K times Won shear rate to the power of n. Yep, that's the Won shear rate. The unit of this one is in Pascal, and the pressure gradient. The pressure gradient is calculated from this equation here. I can copy it to here so that you can see it. Copy it, put it here. Now pressure gradient equals pressure gradient equals this 2 divided by this times from the Won shear rate, which is this one, Won shear stress, and that is the pressure gradient, Pascal per meter. Now, so this is one of the way you can obtain the pressure gradient, and I copy the result and I put it here as an answer for this. I put this here. Good. We don't need so many zero here. Let's say PA per meter. Now, if I change the flow velocity to 2, for example, then I do the same thing. I will obtain the pressure gradient. Let me check to see. I set this one to 2 by changing the value of this one. Let's see how much is that. Yep, that's what we have. And here is the pressure gradient. We don't need so many zero here, so we can just go here and take away some zeros. Now, this is a very efficient way to solve a very complex problem here. In Excel, they also have the other ways to do this. Let me show you how. By using the solver, you click on the solver here, and you click here to select the cell B3, and you make it to the value of 1, which is velocity here, by changing the value of this one. Then you set solve. After solve, it will obtain the result, and the result is quite the same that you obtained before. Oh, I should paste it there for you to see. Quite the same result, right? So I already showed you two methods to use Excel to obtain a solution of the equation. The worksheet method is quite a simple method, and it typically used when you have only one cell that need to change. The solver is a more advanced tools for you to solve a more challenging problem, because you can make multiple cell change. If there are multiple cells that are the parameters of this function, for example, then you can even find maximum value, minimum value, or set it to the value of something. So the solver tool is more powerful than the GoSeek, and it should be sufficient for you to solve any petroleum engineering related problem. Therefore, for the homework, I would recommend you to solve the problem similar to the one before, with a little change in the input to determine the pressure gradient using Excel GoSeek and solver. In the second problems, I would ask you to I made a mistake here. Just change this one to turbulence from in the low space. In the second problem, you are asked to solve this equation to obtain the pi world roughness, which is the relative roughness, using Excel. It's quite an easy way to do that. The third problem is quite the same as the second problem, except you are solving for the Reynolds number. This is very easy to do, and you should be able to do this in Excel. For the first problem, this is a little bit new to some of you. If you have taken the course in fluid flow in porous media, you should be able to grab this concept quickly. But for briefly, the permeability is a tensor, and it can be written in this form. And to find the maximum permeability or the minimum permeability, you can just solve this eigenvalue problem. This one is essentially a cubic equation. And if you expand this equation further, you obtain some equation like this, where kxx, kxy, and the other k are given. Lambda here is the variable that need to solve for. So you need to solve this equation. In the first part of the exercise, I ask you to determine the value of I1, I2, and I3 in this equation here. Basically, when you expand this equation, you obtain I1, I2, and I3. I1 and I2 and I3, they call it the invariance. And in the second part, I have a point in the reservoir with this permeability tensor. I ask you to determine the maximum and the minimum permeability. Determining the direction of maximum and minimum permeability is not required for this one. It just give me the value of maximum and minimum permeability. So basically you solve this problem, so this equation, and this equation always has three solutions, three real solutions. So after you obtain three of them, you should rank them in order from the largest to the smallest. The largest is the maximum and the smallest is the minimum. Also, a student in one of my class at PVU obtained a permeability tensor like this. And I ask you if the student got it right or did he or she got it wrong and why. Basically, you need to determine the maximum, minimum, essentially the minimum permeability, and you check whether the minimum permeability is positive or negative. If it's negative, basically telling us that the permeability in some direction can be smaller than 0, which is not physically possible. In other words, the student didn't get it right. For the problem number 5, this problem related to geomechanics. I hope you already have some concept of geomechanics in some of your courses. Now the stress at the point in the reservoir can be determined by this tensor. And I have a stress tensor like this. And I already tell the student that this is in the normal stress regime. You know what the normal stress regime is? When the vertical stress is the highest and the minimum horizontal stress is the smallest. And you should help me to find vertical stress or overburden stress and the maximum and the minimum horizontal stress. Also, when a student obtains a stress tensor of a point, this is the weakest point on the bore wall of a well, given by this stress tensor. My question to you is, do you think this element is under tension or under compression? If it's under tension, then do you think the well bore will be hydraulically fractured at this stress state? To do this one, basically you need to find the principal stress. And the smallness, if it is negative, then it is under tension. And if the value is smaller than 100, then likely the well bore will be fractured. This is a problem that you will be seeing quite a lot in well bore stability analysis. I hope with the tools that I provided to you in this lecture, you'll be able to solve all of those problems. I have to emphasize that Excel is a very powerful tool to solve many equations in petroleum engineering. And for sure, you have to master this tool when you're taking my course in numerical method. After this lecture, I hope you should be able to obtain the solution of any equation using Excel. And that is all I have for you for today. In the next lecture, I'll be teaching you the bisection and the Newton-Raphson method. If you have any question, please stop by at my office. Thank you for your time.